Okay, so here we are going to be working in 5.2 on calculating the mean, variance, the standard deviation, and what we call the expectation or expected value of a probability distribution. These are different than the mean and such for a sample where you'd say, oh, I got 20 values, so let's just add them up and divide by 20. This is different because what we're doing is we're making a prediction of the expectation or the expected value we should have and how much variation there should be for something that has a set probability. We're going to be using the symbols mu for the mean, sigma squared is still our variance, sigma is the standard deviation, and e of x will be our expected value. To calculate the mean, we take the value, each possible outcome, times the likelihood or probability of it occurring. In a family of two children, the probability of having 0 girls can only occur 1 out of 4 ways where you have boy, boy. The probability of getting 1 girl out of the 2 children can happen by boy, girl, or girl, boy, which is 2 out of the 4 combinations. And to have 2 girls, that's only girl, girl out of the 4 combinations. So these are the probabilities of those individual results. So it's not just what's the result, it's what's the probability of getting each result. And so to calculate the mean, mu, we take the outcome times its probability. 1/4 is the same as 0.25 plus 1 girl occurs 0.5 and 2 girls occurs at a rate of 0.25, or probability of that. If I add all that stuff together, we get 1, which makes sense. You know, we expect there to be on average 1 girl. And that's what this mean is calculating for us. Now this is pretty simple and symmetric probability. There are other probabilities that are not as symmetric. So for instance, if I talk about pizzas being sold at a restaurant, you know, 30% of the time 1 pizza is purchased, 46% of the time 2 are purchased, 17% of the time 3, and 7% for 4. If I want to know the mean or average number of pizzas sold based on these probabilities, then mu will equal the result times its probability plus the next result, 2 times its probability. I get 2 pizzas 46% of the time, times or plus the next result times its probability plus the last result times its probability. And if we multiply these through and add them up, we should get a mu, or a mean, of 2.01. So we're expecting them to sell 2 pizzas on average. Now that might make sense because it's the biggest pile, but if I just shift these numbers around a little bit, that number is going to shift with it. Okay? And so it's not just about the biggest pile, it's also about the distribution of the other results. Now the standard deviation and variance are a little bit more involved, and it takes several steps to get through the calculation. We need to know what x squared is, the probability of x, and we still have to know mu, so we can subtract mu squared. So if we're doing a die, rolling die, and we want to do the mean, standard deviation, and variance, first thing, we are going to have to find the mean anyway. Rolling a die is a 1 out of 6 chance on all of these. And so to figure out first the mean, mu, it's going to be each result times its probability plus the next result times its probability plus dot, 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 dot. This would go all the way through 6 times 1/6. If I calculate that all out, my mean is going to be 3.5. Okay, that's an important number for me to have because it shows up in my formula. If I now go and try to calculate this equation, I need to have x squared. Well, x squared is all of these first numbers. The possible outcomes all have to get squared. Sorry about that. So 1 squared is 1, 2 squared is 4, 9, 16, 25, and 36. We take each of the x squareds times the probability associated with that term. Well, each of these then would be times 1/6. So these would multiply through to produce some new numbers. For instance, I think we get 0.1667. We get 0.667. We get 1.5. We get 6 goes into 16. 2.667. If I did that right. 2 would be 12 with 4. Yeah, okay. 25 times 1/6 should be 4.1667. And 36 times 1/6 should be 6. That is x squared times the probability of x. We need to sum this category. And so I'm going to grab my calculator. And depending on how I round and if I do all this in the calculator or not, it'll be a little different. But 0.1667 plus 0.667 plus 1.5. Whoops. Let me go back. 1.5 plus 2.667 plus 4.1667 plus 6. And I get 15.17. Now you might get a slightly different number depending on how you round, but I'm going to say 15.17. Now that is the sum of all of those. I still have to subtract the mean 3.5 squared. And so if I finish this calculation out, minus 3.5 squared, and I get 2.92. Now that would be my variance. And if I want the standard deviation instead, I would take the square root of that, which is raise it to the 0.5. 1.71. Okay, so that's how we calculate our variance and our standard deviation. A little bit more calculation to do there. The last thing is that the expectation or expected value. It is the theoretical average of a variable. It's like the formula for the mean of a probability distribution. And this is really about figuring out the value of an investment over the expectation. If we ran this 1,000 times, what would we expect to get on average from this investment? Here we have a producer. He's going to put on a show that cost $8,000. Okay, and so if we think about probability, if we think about a probability distribution, we have x and p of x. The first case would be an $8,000 loss if he eats all that money and doesn't put on the show. It says later that there's a $15,000 profit if everything goes well. So those are my couple of outcomes. I could lose $8,000 or I could make an extra $15,000. It says that if it rains, the concert will have to be canceled, and that is a likelihood at 0.3, meaning that not raining and getting all the money is 0.7. If I wanted to calculate the expected value of this investment, I would take my value, 8,000, which is a negative 8,000 because it is a loss, times its probability, plus the 15,000 times its probability. This is like risk management. How big of a risk is this to put on this show? When we calculate those together, we should end up with $8,100. That's what this producer should expect to profit. Now, obviously, he's either going to lose 8,000 or he's going to gain 15,000. But if he were to do this 1,000 times, he would expect to get $8,100 per event on average. Hopefully this helps you and gets you an idea of what's going on in class, and we'll see you next time.